Episode 5, Deep Learning, Demystified. Welcome to AI AWAKEN, the gateway to the minds of machines. Here, we unravel the mysteries of artificial intelligence, one episode at a time. In this episode, we journey into the heart of deep learning, an AI revolution powered by layered neural networks that mimic the brain's ability to learn. What truly sets it apart from traditional machine learning? How do these digital neurons form patterns, make predictions, and even create art? From convolutional networks that power vision to generative models that imagine the unimaginable, let's explore the architectures shaping our intelligent future. Chapter 1: What makes deep learning different? First, let's understand why deep learning stands out from traditional machine learning. Imagine you're teaching a computer to recognize a cat in a photo. In traditional machine learning, you'd manually define features like fur color, ear shape, or tail length. You would essentially guide the model by specifying what to look for, creating a set of explicit rules for it to follow. However, this approach has its limits. It relies heavily on human intuition and can miss subtle patterns that aren't easy to describe. That's where deep learning comes in. Instead of manually crafting features, a deep learning model automatically learns to identify patterns and features from raw data. It analyzes countless images to find what makes a cat, without needing us to spell out every detail. This self-learning ability is what makes deep learning remarkably flexible and powerful. But deep learning completely flips this process. Instead of us explicitly telling the model what features to look for, the model learns these features on its own from vast amounts of data. Imagine handing a child a picture book filled with thousands of images of cats and dogs. You don't explain the differences, you just let them observe. Over time, the child naturally learns to distinguish cats from dogs without needing you to point out each specific trait. Deep learning works in a similar way. By processing massive data sets, it uncovers patterns, correlations, and unique features all by itself, enabling it to recognize complex concepts without human intervention. This ability to learn directly from data is what makes deep learning so revolutionary. Example 1: Personal recommendations. Think about how streaming services suggest movies you'll like. Traditional algorithms might just look at your past choices, like genres or actors. Deep learning, on the other hand, analyzes complex patterns: how often you watch, how much of a movie you complete, or even what time of day you usually watch. It learns your preferences without needing predefined rules. Example 2: Voice assistants. Your voice assistant doesn't just match sounds to words, it learns your accent, speech patterns, and even the way you pronounce specific words. Unlike traditional systems that just follow set rules, deep learning adapts to your voice over time. This ability to self-learn and adapt is what makes deep learning fundamentally different. It's not just rule following, it's pattern discovery and interpretation on its own. Chapter 2: What are neural networks? Neural networks are the backbone of deep learning. Imagine them as a collection of tiny processing units, similar to neurons in the human brain. These units, called neurons, or nodes, are organized in layers: input, hidden, and output. Just like the brain has neurons, a neural network has nodes. These nodes are organized in layers. One input layer takes in raw data, like images or text. Two hidden layers process and transform the data through mathematical operations. 3 output layer produces the final result, like a classification or prediction. How they work. Data flow. Data passes from one layer to the next, where each node processes the data slightly differently. Learning process. The network adjusts weights during training to minimize errors. Activation functions. These functions decide whether a node should activate based on the input it gets, similar to neurons firing in the brain. Let's simplify it. Imagine you're baking a cake. You start with raw ingredients: flour, eggs, sugar. The input layer is like those raw ingredients. The hidden layers are the mixing and baking process, where the ingredients transform. Finally, the output layer is your finished cake. In neural networks, data flows through these layers, getting refined and processed at each step. Example 1. Handwriting recognition. Imagine writing a digit on your phone. The input layer captures the pixels. Hidden layers analyze strokes, shapes, and patterns. By the time the data reaches the output layer, the network has identified your number, say, a 7. Example 2. Voice to text. When you dictate a message, the network's input layer records the sound waves. Hidden layers break down the audio into phonemes, recognize words, and understand context. The output layer then converts your voice to text. This layered learning and refinement make neural networks highly efficient in recognizing complex patterns. Why use neural networks? They're excellent for complex tasks like image recognition, natural language processing, and voice recognition, where simple rule-based methods fall short. Chapter 3, Key Architectures Explained. Now, let's break down 3 key architectures: CNNs, RNNs, and GANs. CNNs, Convolutional Neural Networks. CNNs are specialized for analyzing visual data. Think of them as a set of eyes scanning an image piece by piece, just like how you might study a picture closely to catch every detail. They're especially good at detecting edges, shapes, and patterns. That's why they're widely used in image and video analysis. Example: facial recognition. Narrator: your phone's face unlock uses CNNs to detect your facial features, like the distance between your eyes and the shape of your nose. RNNs, recurrent neural networks. RNNs excel at analyzing sequences, such as text or audio. Imagine reading a sentence word by word, remembering the previous words to understand the context. RNNs do something similar. They loop back on information to remember previous inputs. This makes them great for tasks like speech recognition or language translation. Example: predictive text. Narrator: when typing on your smartphone, RNNs predict the next word based on your previous text, just like how you can guess the end of a familiar sentence. GANs, Generative Adversarial Networks. GANs consist of 2 networks, a generator and a discriminator. The generator tries to create realistic data, while the discriminator evaluates it. It's like an artist drawing a portrait while a critic judges its accuracy. Over time, the artist improves as the critic points out flaws. This back and forth makes GANs capable of producing highly realistic images. Example: deepfake videos. GANs are behind deepfake technology, creating videos where a person's face appears realistically swapped onto someone else's body. Deep learning isn't just shaping technology, it's reshaping our world. From teaching machines to see and hear, to enabling them to create and innovate, we're on the brink of a new era where AI learns, adapts, and evolves just like us. The journey has just begun. Subscribe to AI Awaken and be part of the revolution. Stay curious, stay inspired, and get ready to dive deeper into the future of intelligence.